A front is a boundary between two air masses. When a colder air mass is advancing against a warmer one, a cold front is depicted at the boundary using a blue line with triangles pointing in the direction of movement. So in this map, the colder air is here, warmer air is here, and the entire system is moving to the south. This two-dimensional depiction doesn't give the whole story, though. These drawings, by Sloane, show what a side view of an advancing cold air mass looks like. The cold air moving from left to right in this picture is forcing the warmer air ahead of it up away from the surface. Sloane penned a wonderful description of the activity at a cold front. It is like the fuss kicked up along the front end of a barge, the curling wood shavings that wind up along the front end of a plane's blade, the piling snow in front of a snowplow. When a cold front is fast, its downward snout roots all the warm air in its path, sending it aloft vigorously into a teeming mass of howling black cloud fury. Cold fronts usually move more quickly than do warm fronts, typically at 15 to 25 knots. This question, though, specifies a fast-moving cold front, which means at least 30 and as fast as 50 knots. This higher speed means that the vertical movement of the warm air being shoveled out of the way is even more intense. When air is forced upward, one of the three requirements for a thunderstorm is satisfied. The other things needed for a thunderstorm to form are an unstable atmosphere and moisture. The warm air is being actively and forcibly pushed upward, and if it is moist and even slightly unstable, when it reaches its dew point, it will begin to condense into clouds and continue to rise. The intense vertical lifting motion imparted by a fast-moving cold front can definitely cause thunderstorms. Answer B. Light showery precipitation is more likely with a slow-moving front, not the violence of a fast-moving cold front. Surface friction, which causes wind speeds to slow and change direction near the ground, is not caused by fronts, though it does slow the frontal passage right at ground level, which causes it to have a steeper vertical cross-section, a factor which contributes to the severity with which air is lifted at the frontal boundary.